Hello, welcome everyone. Sebastian Buczyński will be talking about clean architecture. And if you have any questions, please do join us on Slido. The questions will be answered before the end of the talk. Thank you.
So before I start, I have to warn you that I gave this presentation already several times, so if you have seen it before, please be aware that there will be not much new content today, unless you are from Wrocław, because this is a bit different presentation that I gave there at the beginning of this year. So starting off, a few words about myself. I'm a conference tourist. I travel to every nice place when they have, by accident, Python conference. For example, Dominican Republic this year. I give talks there. I work as a developer at Estates Next company, and their department at Bucz. I co-organize the Python Bucz meetups in my city. And I also write a blog under breadcrumbscollector.tech. You will see the link in below on the slides all the time. So I'm here on the mission because last year, I also was giving a talk at this conference, which was entitled "Why Do You Design Patterns in Python?" The title was a bit a deceit, because of course you need to design patterns in Python, but only some of them may be implemented maybe simpler than you imagine in Java or some other scripting languages. So apart from this conclusion, the last slides also contained some kind of jokes. And although it's very easy to make fun of language such as PHP on a daily basis, and you can find a lot of occasions to just have a good laugh, I am here today because I think that in 2018 the joke is actually on Python. Software engineering is not a discipline that is somehow widely spread or popular in conference agendas, as compared, for example, to those of PHP. So I'm here today to show you some topic out of this discipline, which actually I use in my daily work and helps me a lot, and actually improved my project a bit. So this is called a clean architecture. Clean architecture is an approach that's promised to give you some advantages. Amongst them you will be independent of framework, not in the matter that they are actually not used or something like that, but your business rules shouldn't depend on them, or you shouldn't be confined by these frameworks. You will get an excellent testability. You should be able to write tests for all the important parts, real unit tests with ease, and they will be very, very fast. You will be independent of the UI. UI shouldn't shape your business logic, and independent of database, and actually every other stuff. So it means that you can distill your business logic requirements from customers to be put aside, these lesser concerns. And this is what clean architecture is all about. It's about putting your customer's concerns right above all the lesser stuff. And I won't be talking in void. So there is an exemplary project about auctions online. This somehow can resemble what Allegro used to be like a few years ago, when you just bid it on the auctions and have a possibility to win them. To describe such a system in few exemplary user stories, I could give examples like that. So as a bidder, I would like to make a bid on the auction, to win it. As a bidder, I would also like to receive email notifications if I am the winner, like this right now. And as an administrator, I would like to withdraw bids that I suppose that are somehow made out of deceit, or maybe someone asked me to do so. And if I were to implement such a project using Django REST framework or any other standard crude framework in different languages like Ruby on Rails, then I would probably start my analysis. Okay, so the frameworks are such creatures that are composed of some building blocks. Using these building blocks, you compose them together, arrange them, and then you can achieve the goals that the project is putting ahead of you. So in Django, and also in Rails, the central building block of the framework are models. Everything revolves around them. As you can see from these directed arrows, actually everything comes down to the models. So obviously it means that before I code something real and I show it to the customer, I have to start with the models. So to start the analysis of the user stories, I will treat them and find the nouns, because they will be probably the candidates for models. And of course, this is, in this case, true. So I will code these models, and to demonstrate the clean architecture, I will use the third user story, withdrawing a bit. I have models for options, I have models for a bit. What stops me from using a Django admin? It takes literally 6 to 8 lines of code to produce such an admin panel, which actually is pretty useful. It has these checkboxes, which I can use for just withdrawing a bit. But no. This is not just a simple operation that I can just delete the row from the database. I still will have to calculate if there is a new winner. I still will have to send them a notification, hey, you are now the winner. And perhaps I will also have to recalculate the current price of the option and so on. So there is more logic behind this. I just cannot simply delete rows from the database. Luckily for us, Django has many places where we can put our custom logic, and this is true also in this case. You don't have to read the code. I will be explaining it part by part without delving into details. So what you can see there is that I'm just getting the IDs of the bits that I'm trying to withdraw. Then using the option that I'm editing, I'm asking the option model to actually do something about these bits because I'm about to withdraw them. So this will cause our logic to be involved and calculate current price and so on. And in the end, I just notify the new winners, which could be if there will be some changes. And if we look at this case from a different perspective, like system analysis, you will see that this is following scenario. On your left side, there is an actor who actually interacts with the system. In this case, this is some kind of administrator. And in the middle, there is a system boundary, namely an interface, which he specifically used to interact with the system. And on the right far side, your left side and your right side, is a use case, which meaning this is the concrete scenario under system is being used. And with Django, and the example of code I just showed you before, this is knotted together. You can't tell one from another because they are not separated in the code. It's just one piece. So if I were to expose this functionality, for example, for using Django script to be used for some bots that will automatically detect frauds and things like that, and automatically withdraw bits, I would have to pull this code elsewhere, for a function, maybe for a class. So it means that for every such a building block in this analysis, for every use case, I would have a separate class or maybe a function, whatever works best. And this is actually the first building block of the clean architecture. This is a use case, or sometimes called an interactor. I prefer the former because it's shorter. And if you could think of a use case, this is some kind of a conductor who keeps an eye on the process so it's carried out properly, as it is imposed by some business requirement. And okay, so how to test it? Of course, our business logic is still coupled to a framework, so testing it would also force us to somehow conform to the framework structure. So the common idiom I'm seeing in Python, this in Django projects and other applications, is that we are testing using views. These are high-level tests, maybe integrations, maybe end-to-end. And what are we doing there? Basically, we are setting the stage first, so we are inserting all the required models to the database. Then we are calling our endpoint to just invoke some business logic, and then we investigate the response. And these tests are a bit of scam because they are taking way too long time, and whenever our system is complicated, it requires more and more effort to just insert new models that are required. And if we have a lot of cases to check, then we are going to lose a lot of time on just waiting for this. So this has a very, very inconvenient cost, which of course is time, your time, wasted. And I wrote an article which explains exactly how much time do you waste and how much can you spare if you would be testing on a lower level. There is an article in the Python PL book, you can find it on GitHub. And also there will be links to slides in the end of this presentation, so don't worry, don't lose it. But going back to so how the test should look like, at least according to books, some articles, manuals. So usually we'll find the example that's starting off with testing a calculator, which adds two numbers together. And of course this is as simple as impractical, it cannot be simply applied to the real world example. Or is it, actually? Because what can we see there? This function is very simple and has some distinctive features that make it so. To start with, it doesn't have any external dependencies. It doesn't use database, it doesn't use current, date time, and so on and so on. All it needs to produce a result are these arguments inside that we are giving to it. And independently of the position of the sun in the sky and so on, this function will always produce the same result over and over again. This is something called in the functional programming a pure function. And this is of course very easy to test because it has no dependencies and no side effects. So if we would want to have our business logic to be as easily testable as this, then we have to make some adjustment to it, to get rid of dependencies. And some people think that writing better tests is a matter of how many Python plugins you have. This is not true. You just struggle more and more, patching where you shouldn't do this, and in the end your tests are not so great. So the first step in getting rid of dependencies is to actually find them. This is the same code as I showed before. So in the highlighted area, we see that this is an actual external dependency because I'm coupled to Django ORM and I'm fetching some models to do action on them. And if I would like to actually get rid of dependency on Django ORM, then I could implement a solution that is widely used in programming, which is I would introduce a layer of abstraction. And in this case, this is something called Auctions Repository, which has two methods, as we can see in this example. This is get, which accepts an auction ID. This is save, which accepts an auction model. And the thing that I can imagine, because I still don't know what it is that it could be written as some abstract class like this. So, okay, so looking at this snippet of code and the previous example, all I need to know when thinking about my business logic is that I actually need that it requires something that has a get and save method with proper arguments. And this is actually the second building block of the clean architecture, which lets you separate the business logic away from this external world. And this is called an interface or board. But this is a very simple example because saving to database is nothing that's really very exotic. Another example would be, imagine you are to integrate with some payment providers. There are many of them on the market. And actually switching from one to another is not such an unrealistic scenario, given that if you do have a real big volume and you do a lot of transactions, then probably the business guys can negotiate some better terms and some discounts from the big players in the market. And I know how tedious integration with such models can be. For example, it will certainly include some transport intricacies. Maybe there is a REST API, or maybe this is a plain old good SOAP with sending XML over the network. So these details can be a bit disturbing. Maybe the protocol of sharing data is even way more complicated. Maybe you not only have to expose some endpoint to access webhooks, but also you have to, for example, poll their API from time to time and checking if there is any new data. So these details of integrating with one payment provider can be actually pretty complex. But the goal is that your business logic doesn't know anything about it. There has to be a very simple interface. I mean, it's so simple, it should be obvious how to use it. And you shouldn't be thinking about such details when you have just a simple interface, like this. Okay? And of course, every abstract class has a corresponding concrete class which implements the logic and actually do something. And in this simple case, just for a moment, this will be just naively returning the option model query, but the option ID. I will expand it further in a moment. For now, it's just another, every port, every interface has an implementation, it's called adapter. Okay, so of course now our use case, so our business scenario requires this to work. And we don't want, the whole trick comes down to that we must not know at the use case level that we are using Django. Otherwise we really aren't decoupled, we are still depending on it. So one of the examples of composing these objects together, so the use case doesn't have to, is not longer responsible for knowing what it's using, is passing the arguments via standard init, then assigning it, and then we can use it as like this. Pay attention to the type field here, because I'm annotating that this will be the abstract class. So eventually use case doesn't know that it's used Django. Okay, of course, such an object composition would be very practical and tedious and error-prone. So there is, of course, a better way, a better pattern, and this is called dependency injection. This is some kind of centralized configuration, like a giant dictionary, that whenever someone asks you, hey, give me an options repo, I will give him Django options repository instead. But of course this is hidden, so from the outer world, so use case would know that he's using Django. And there are few libraries in Python to do such things. One of them is inject, which you can see here. There is also a second one, which is injector. So what we actually gained by introducing an extra layer of abstractions, except for complicating stuff. So, of course, now it's easier to reason about the business logic itself, because when things goes out of sight, it goes also out of mind. So I no longer have to think about what is going on underneath. Now we are able to write true unit tests for the use case, so you can test things really low, and it will be very fast and very easy, because also you have a very simple way how to mock these dependencies, like in this case, putting it through standard init method. You don't have to mock or patch. And the thing that is a real-world example is that the work on user stories can be parallelized. And this is a real-world example. When we started a new project similar to this one, first there was a 2-hour session of pair programming with my fellow programmer, where we implemented some really basic stuff and just the interface for options repository. So while my colleague Dominika continued to work on the use case, I started working on Django options repository. So in the end, we were working together at the same stuff. And because this was the very beginning of the project, we wouldn't step in our ways. But the biggest killer feature for me is that decision making can be delayed. So as I mentioned, switching payment provider may occur, but also it may happen that businesses are so indecisive that they cannot choose which one to start with. So instead of blocking entire development, we can, for example, analyze a few common payment providers to see how would the typical implementation look like. Just provide a dummy implementation that would actually do nothing or just always respond that, hey, payment succeeded. So we can just move on. And later on, when we have these payment providers selected, we can just use it and start implementing the real implementation. This is just the object-oriented programming done right. So all of these come from the things that are encapsulations, moving away, details, and so on. But I like to do that, because actually the true logic is still coupled to the database, because I'm still using auction model from Django. So we'll get into it in a second. So the final building block of clean architecture is called entity. And entity stands for any business unit that you would like to represent, like in this case, an auction. But pay and note, this is not the auction alone. It also has bits inside. So this is a bit more sophisticated than just a simple model. Another thing to notice is that this is pure Python class. It doesn't have any dependencies. It only depends on the interpreter. So, which makes it also very easy testable. And we can actually work on this regardless of what framework we are using. And of course, the real-world adapter or interface adapter will also look a bit more differently, because first we have to fetch all the models and then translate them to entities. Question I got asked once was, what's the actual difference between entity and model? Because actually I can still have a model, and what's the purpose? So first of all, the models sometimes can be just the dump bugs of data. So they have some properties, we want to use them in our scenarios. But the entities are very different. This data, there is only a reason for gathering some data into entity is that we just cannot change this data independently of each other. So the example with auction works very well, because I cannot just change the current price of the auction without messing with the bits or the thing opposite. So all this data that is interdependent with each other should be grouped into entity whenever possible, and only then change together. So we have a portion of our business rules encapsulated in a single object, which again is a pure Python. So the thing that we are trying to avoid when using entities is to directly changing inner details. Because in such a way we are stuck together with the list implementation of bits. We cannot substitute it for other collection, because on the outside we use it like this. So we always ask our entities to do stuff for you. We don't make it directly. And this is called tell don't ask principle. So another difference is that the entities, as I said, should be formed around data that must be changed together. So they actually represent a graph of objects, not a single one, like in this example. So we have a graph where root is auction and there are some bits beneath. So to sum up the building blocks we have all together, so there are some entities which represent our business logic around data. There are interface ports adapters, which are plugins of external world to our logic. And there are use cases of interactors which stand for all the processes and so on. There's also an extra blog I haven't shown in this presentation. It's called Presenter, but it's in the exemplary project or the article that is linked in the description later, so you won't lose anything. But of course, that's not an exhaustive list. It doesn't mean that you are limited to those building blocks. The clean architecture gives you a solid scaffolding, which you can use more and more patterns from more sophisticated techniques like domain-driven design and so on. But this around forms a solid foundation which you can build upon everything. It's not over yet, because it doesn't mean that, okay, so I'll now write entities and so on and use cases. The clean architecture is a layered approach, meaning that these building blocks are actually arranged in some kind of a layers with some restrictions around it. So in the middle, when there are no dependencies, no external world knowledge, is a domain. And domain is a place for entities or any other objects that will contain so-called enterprise-wide business logic. So these are rules that have to be true, have to be enforced, no matter who is messing with the system. Is it the user? Is it an administrator? So for example, if this is an e-commerce, probably there would be a place for enumeration with possible order statuses and so on. And in the auction, this is also true, because no matter who changes, removes, or adds bits to the auction, we always have to recalculate the current price. The second layer, this is an application. An application is a place for use cases and all the interfaces. So these two layers actually are responsible for your business logic. And please note the arrow here, which points towards dependencies. So domain doesn't depend on anything. It doesn't know anything about our outer world or things like that. Application, on the contrary, can use everything it finds in the domain without any restrictions. But in the opposite direction, this is forbidden. You must not import, use, accept by name anything from the outer layer. And the same remains true for other layers. For example, infrastructure, which will contain all the adapters, implementations, and things like that. So again, you can use application, you can use domain, but you cannot use it in the opposite direction. And this is just example. There may be more layers as you see fit, but the reason is that the result is that whenever something changes in the external world or in the infrastructure, your application domain remains intact. Do not enforce any changes on that, because we simply don't know anything about how to work there. But on the other hand, if you do some business changes, there are some new requirements, then you expect the outer layers to just conform. So if you change your entities, then probably you will have to do some adjustments on application and infrastructure. Okay, but the overall principle, so-called the dependency principle or the dependency rule, states the same. You must not use, import, or accept anything from the outer layer when you are in an inner layer. And this makes that your business logic, which should be actually contained in these two inner layers, has some sort of a boundary. Because the outer world uses different formats of data, for example, these Django models, which are not to be understood by the inner layers. So that's why you have to translate it to a format that actually is comprehensible by these two inner layers. And I would be a hypocrite if I would tell you that this approach is great and it doesn't have any downsides, or there are no hard spots or things like that. Of course it is. And there are few of them, actually I don't think that even have the best solutions to that. Maybe because we are in dynamic type language like Python, but let's tackle them one by one. So first thing you have to forget about is non-idiomatic idiomatic framework use. We'll no longer be able to write code according to the manual, according to tutorials. Because they assume a different approach, of course, and you are actually on your own with figuring out what would fit best. But you have just these dependency rules and building blocks to achieve your goal. And when we are at the frameworks, a quick note, because I actually tried to all of them. So with Pyramid and Flask, this works actually seamless. It's pretty much fun, and there are no big problems because they are decoupled by design, and they do not expect you to write the code as they see fit. Django is a bit different story because it is a sort of opinionated framework, meaning that it makes all decisions for you and assume that you will be working as authors of the framework foreseen, which not always is true. And so I discourage using Django with this, unless for educational purposes, or if you like pay. Otherwise it doesn't make any sense. At least not for production. So another downside is that you will write more code. And not only more code for abstract classes, but also the code for translating from one object to another. So this also may bite you in the beginning and discourage you from using the clean architecture. You will see some places where there is copying data between objects, which actually may not make sense, at least in the beginning. When, hey, I'm just copying data from the auction model, which is exactly the same fields as my auction entity. And this also may discourage you from using it. But from my experience, after working as several months on a project using clean architecture, I can tell you that this in time will differ. Entities will not have the same fields as the model, eventually. And the validation, this is the biggest flaw, I suppose. There is no best recipe for doing the validation in the model. So some of us may be satisfied with just validating on the API level, and then you pass down to the domain or application and assume, okay, everything is fine, I did the validation. It may simply not always be true. Some libraries will have those. Although I wouldn't choose usually Django for my projects, I still admire its serializer for Django REST framework, as they are very easy to use. Some other libraries, more framework agnostic like Polander or Marshmallow can always help. There are also some libraries for enforcing strict type checking, that using type annotations will raise exceptions if you pass something that's not as you expect. But that's just one side. Because even if I'm getting something, like using decimals for money amount, and okay, it has 2 decimal places, so it looks fine. It's not negative number, it's positive. But what then? The decimal allows for a much wider range of values that actually the concept of money can be. Because money usually assumes that you have 2 decimal places, but there's also a currency that is involved, and things like that. So instead of struggling very much with passing decimals over and over a place, you can use a pattern that is known as value objects, meaning that for every concept, like which could be represented as a single value, like this decimal on money, we can create our own class that will automatically enforce all these rules and can be passed around in the domain and application safely. So when we can accept on the API string, convert it to decimal, or maybe even straight to the money class. So when we get such a money class in the use case or in the entity, we know it's valid, because the value object guarantees that. The last risk is the risk of over-engineering, because suddenly you start seeing things like, oh, let's put another interface there. Oh, there I have a very simple project, but why not use clean architecture? And things like that. Of course, this should be avoided. The simplest solution that works is always the best one. And even in the projects when there is some aspect that is pretty complex, like in the auctions model, the auctioning itself, it is really complex. There are many cases that needs to be tested, needs to be coded, but at the same time, the same projects need some registration, some authorization, some saving user preferences. Is putting the clean architecture there a good idea? I wouldn't be so sure. Maybe there should be a way how to use the best of 2 worlds. But I'm 100% certain that there is no need to apply clean architecture to every single project. Of course, this would be shooting from a big gun to a mosquito. But actually, there are some cases when clean architecture actually pays off and it really proves its value. So, first of all, if you have lots of test cases, check, and testing using views is just a scam and takes too long time, you can't work in a TDD cycle because you are getting feedback after 5 minutes and not after half a second, and so on. So I mentioned that the tests are very simple, but I haven't actually shown them, so now I will make it up for you. So, testing entities is a child's play, because they are pure Python class, they have no dependencies. All scenarios that are formed around this data that entity encapsulates can be coded really simple, and they will be very fast. So, I believe that in this example, in a real world project, we had something like 20 test cases for the auction entity, and it actually exhausted. It was 100% exhaustive. We tested everything, and that we could think of at least. Testing use cases is not that much harder, because then you have again a very simple way how to put your mocked implementations instead of adapters you expect to have, and then you can check if your use case, meaning your business process, is actually performing as you expect it to be. So again, these tests are very simple, very fast write. And the other thing is that you can still delay your any project decision, your any business decision. And this is especially vital when you are building something for the first time and you are not even sure. So one of the definitions of the architecture that you may encounter is that architecture is something that is very hard to change once you decide upon. So instead of committing yourself to some choices in the beginning, when actually you know the least of the project you are trying to make, you can delay these choices to a later stage when you will know more than just now. Because in the beginning, usually we know the less. And with time, of course, everybody is wise after choices have been made, but it's usually too late to undo them. So yeah, that's a big deal. And last but not least, is a complicated domain. When the project or the concepts are so complex that you just can't wrap your hand around it. There are so many terms new to you, so many intricacies, so many interdependencies, that it doesn't simply map into your mind from these descriptions to a database object. That this also may be a great candidate for using clean architecture. So, as we are drawing near the end, there's of course a list of articles and stuff that was used to create this presentation. Actually, everything that I said is unfortunately only in Polish, but it's just temporary, available in the article, which is linked. I just shared the link to the slides. And this would allow you to just get familiar with these ideas in a more calm environment than on the presentation. And just a shameless plug, there is a lot of knowledge that just couldn't fit into one talk. So I decided to write a book on implementing clean architecture. There is not much data, especially not in Python, about it. So I decided to fill the gap. And as for the talk, that's all from me. Under this link or in this QR code, you will find the link to the slides and to the some materials also. So that's everything from me, and we'll just continue the QA session.
Hello, we do have a few questions, and we will read how many we can. So the most important question is, doesn't this mindset, injections, abstractions, go against the Zen of Python? Why not just switch to Java?
To really confront this statement, I would have a concrete example of what actually in Zen of Python is contradiction with the clean architecture. Because Zen of Python actually states that the simple is the best, blah blah blah, but of course only the simplest solution that works. So I will go back to the example of the PHP guys. So of course PHP is a much worse position than Python because they were doing web programming from the beginning. And if you look what they evolved into right now, how many experts are there in their communities and how software engineering is common amongst them, at least in conference agendas and in discussing groups, that you start to wonder. So the same is true with Ruby, although all Python programmers, including myself, tend to ignore the Ruby existence. They also actually shifted a lot towards this software engineering movement. So my point is that when you are a data scientist, actually this might not be very useful to you. When you are making some simple web applications, it's also may be useful to you. But as the systems have evolved and they are getting more and more complex, you also need more sophisticated techniques to actually get it right. So I don't believe that this is true. Although I must admit that sometimes I really lack some things that are present in Java and I don't have them in Python. But still, I can cope with that. Yep?
Yeah. So can I add something here? So, as you remember, the first line of Zen of Python is beautiful is better than ugly. And I think that clean from the clean architecture is synonym to beautiful. So no, it's not against Zen of Python.
The next question. How about using ravioli-oriented architecture instead of lasagna?
Okay, so I must admit that I don't know the term, ravioli. Maybe the obvious question would like to help.
Microservice architecture.
So one of the approaches is that actually every microservice is a separate little architecture. So that's a different stuff. But regarding code packaging and arranging them, of course, when you have one big clean architecture stuff, when all use cases are together, or entities are together, and or adapters are together, it will become a mess regardless. So you will need another packaging approach. For example, you could start cutting these into separate contexts, into separate things. So for example, into this auctions example, there will be a separate package with the infrastructure application domain inside for the auctioning itself, and there will be another such package for another aspect of this project. Like for example, for gathering marketing preferences and other stuff that's not actually directly connected to auctions. But if I put just everything together, and this will always become a mess.
Isn't the reason we use frameworks to have done this stuff for using the frameworks actively and using the tools provided by it, not to waste time on abstracts?
Okay, so I love this question because actually I feel that the abstractions that are given us by frameworks are sometimes not powerful enough to express how rich and how complex the domain really is. I mean, it's like so someone asks me to build the Eiffel Tower and just give me a little Lego blocks 4x4 and do it for me. I mean, okay, it's possible, but I would do it more. It would be better building if I had another building blocks which I can actually compose. So the stuff that is made by the web applications or web frameworks is specific to the web, and it actually stay there. Clean architecture says, and other movements like domain-driven design, that actually what it has in the business logic has nothing to do with the web. Like auctioning, actually this is very old stuff. People were doing public auctions for, I believe, hundreds of years now, and there was no word about the web. So why should we mix these two together? Because apparently they have nothing in common.
How big is the performance cost of such abstractions? How hard is it to optimize for the current stack with so much abstractions around it?
Okay, so this is another very good question. So the cost for the abstraction when we have this use case and simply injecting a few classes is really negligible. It adds really very little to the cost. But of course we provide it and measure how things are working. So for example, in another project we got SQL Academy, and of course the overhead of the ORM, even when used for simple things, were much higher than using clean architecture. So I think that somehow exhausts the question. But on the other hand, of course we do optimize and do measure, but again, it were more things like optimizing database queries, preparing a special model, read model, so the reads are very fast, and things like that. But there is a hidden truth in this question, because the Python doesn't, at least not CPython, doesn't have JIT, just-in-time compilation, meaning that every abstraction has its cost. That's not true for PyPy because it would cut them. But in the long term, of course, it has some cost, but it's really negligible. At least unless you are complicating stuff a lot.
Is it profitable for the client? It takes more time and produces more code, opportunity for bugs. In my honest opinion, it only promises possible profits in the future.
So obviously, it's not. The profits are not visible. Sometimes for a few first months, up to 2 or 3, I guess. By then, the project becomes so complex that now it starts paying off. And the customers I worked with using this approach were actually delighted with the result. So I think it's still a juice worth the squeeze.
Does it make sense with active record model?
So the active record is exactly the pattern that stands behind Django ORM. So there are some discussions on the internet that states that actually your entities are not that complex that you would need a graph of objects, only a simple model would do, then actually you can do it. That's not advised, but also there are no hard arguments against. But again, doing this is just asking for trouble, but if that suffices, that maybe the clean architecture is also not the start. But since the question got here, there was also some library written by Jakub Skałecki, and I believe it's named Business Logic or something like that, which actually distills these use cases layer or something like that, and allows you to use Django models with it. So you get some, again, layer of some benefits of clean architecture or other similar approaches, but with no cost of translating entities into models and etc.
Is it even worth considering in existing projects? Wouldn't it be only worth to use in projects where frameworks have very few tools we do need to do it anyway?
So I'm not sure what does it mean to that frameworks have very few tools. Do we need to do it anyway? So in the existing projects, I think it's hard. It's as hard as undoing every bad decision or decision that you committed to and now it becomes apparent that maybe there is another way to do it. I don't know, honestly, because it depends on the project. If this is actively developed, then I would say yes. If you are actually moving towards something that will require it. I'll give you another real-world example. Recently I was asked to assist with some refactoring of a project, which had some code written in Python, some code written in PHP, and the business logic was duplicated in both of them. So that's a serious technical debt. And the idea was that actually let's move away with all business logic from Python to PHP and expose it as an API. Okay, so then I come in and propose, hey, let's distill this layer of use cases and provide some adapters that will be initially, so we do not freeze code for a few months and we can deploy to production all the time. Let's just wrap the business logic in the adapters in the Python and later just replace function y1 with calls to PHP API. So this allows for steady migration. So it depends, basically.
Great talk, thanks. When are you going to open office in Silesia?
I think there is a STX next office in Wrocław.
How to decouple static assets HTML templates from the logic to benefit from CDN?
Okay, so this probably should be answered by showing you the presenter. So this is something a bit similar to ports and adapters, but actually I have never applied clean architecture to a project when the web application was also rendering views. This was always a matter of another separate front-end application. It was written in Angular and React.js. So I can't really answer this question.
What is time to money market cost of the design, assuming a case where we do not switch back around?
So this question is impossible to answer because I would have to have two identical teams that were building the same solution and compare it. I can only say that whenever we use this for the first time with this options project, quite similar to this, we had 1 month and 1 week to deliver the entire product, and we did it. Even though we were just learning the clean architecture stuff and so on. So it's feasible to do it.
Aren't slow tests an indicator of a slow system under test?
Not necessarily. If these tests are doing database operations and always expect there to be an object in the database, then this probably means that you're testing the wrong thing. The article I wrote explicitly shows it. Like, for starters, testing using Vue is 12 times slower than testing using plain old Python object. It's not always the case. I mean, the saving, for example, model to an in-memory database may be very fast, but if you have 1,000 of such tests, it always be slower than just testing in memory of plain Python code. And one curiosity, one interesting fact, is that when I profiled the code of Django that we have used, for example, reversing URL takes about 20% of time, which is a lot for a test. So if this is the case, then the web framework is slow, not my product.
Where are frameworks on the layers map?
So depending on the framework, usually on the blue, meaning external world, but if we are having so if we are having Django, then of course we would be using Django ORM, so the framework will be present both on external world layer and in the infrastructure layer, because some things will be actually dependent on them. This is not true for Pyramid plus SQL Chemie, because SQL Chemie is somehow separate from it. So I believe these answers the question.
Thank you very much.
Thank you very much.